Hello, my name is Pipyomia and this is my presentation for Machine Learning Coursework 2. In this assignment, I designed and implemented an image classification system using a Convolutional Neural Network or CNN. The goal is to train a deep learning model that can recognize objects in color, images, and correctly align them to one of 10 categories. I used Python and TensorFlow in Google Colab with CPU acceleration, and the project followed the official coursework guidelines. About this coursework, contributes 40% of the module grade and requires us to implement a neural network project for image classification. The process covers data preparation, model design, training, evaluation, and result interpretation. I also needed the document to work clearly and record its representation, demonstrating the key features. I enclose the CIFE or dataset because it is a well-known public dataset containing 60,000 color images. To make my vision unique, I replaced the 4 layers with custom class name, helicopters, cars, and such as loading the code cell, print the class names, and 1 or 2 XML images. The dataset is automatically downloaded using the TensorFlow Keras APIs. Each image has a size of 32 by 32 pixels with 3 color channels. Before training, I normalize the values to the range 0 to 1M, split the data into 80% training and 20% testing. To improve generalization, I also apply data augmentation, which randomly floats, rotates, and zooms images. This ensures the model learns to recognize an object when it appears slightly different operations. Model architecture. The model I built is the Convolutional Neural Network with an input layer, subtracting layer, and one output layer. The structure is as follows. A Conv2D layer with 34 filter and initial feature extraction, mask Boolean layer to reduce dimensity, and Conv2D with 64 filter, then another Boolean layer to capture higher level patterns. Attack Convolution 2D layer with a 128 filter, followed by dropout for regularization, a flattened layer, and a dense layer of 128 neuron. Using the real view activation, finally a dense output layer with 10 neurons and software activation to generate class probabilities. The model was complicated, combined with the optimizer and square category cross attribute loss and accuracy was used as the evaluation matrix. This is just running the code for the image processing model. The model was trained for the 10 approach with the batch size of 64. I implemented 2 callbacks, early stopping, and model checkpoints to avoid overfitting and save the batch model to run automatically. During the training, the validation accuracy increased steadily, demonstrating that CNN was learning meaningful features. After the final approach, the best validation accuracy reached approximately person with the low loss. And the training loss scrolling and the two paragraphs, accuracy and loss versus average. Here we can see the training validation curves, accuracy improving on the left and loss decreasing on the right. The curves are relatively smooth, indicating stable learning. Evaluation and training was complete and evaluated the model on the ancient test data. The final test accuracy was around 8%, showing the strong predictive performance. The conclusion material visualized how well the model classifying each classes. Most prediction fall along with the diagonal meaningful graph classification. A few errors occur between visually similar classes such as Spoker and Computer, which share similar scopes and colors. I also generated a sample prediction grid to visually compare accurate versus predicted labels. Green ticks represent the correct prediction and red crosses show misclassifications. This project shows CNN can automatically learn complex visual features without manual extraction by applying regularization and optimization. The model archives good generalization on new data. One limitation is that dataset images are small, so final details may be lost. Future workflow include using higher resolution datasets or employing transfer learning with a pre-trained model such as VGG16 or MobileNet. They include conclusion. This coursework successfully implemented a complete image classification pipeline using a convolutional neural network (CNN). The model demonstrated reliable accuracy on the modified CNFR10 datasets and produced clear visual evidence of the learning through its evaluation metrics and plots. I gained practical experience with data pre-processing and CNC architecture design, hyperparameter training, and performance analysis. Yes, that's for all my thoughts on this module. And yes, thank you for watching my presentation.